Good evening, and welcome to another episode of That's Definitely Weird. Tonight I'll be your host. I'm Grindhouse Zombie. I'm here with my buddies Clark, Seth, and Ro, and also Seth's girlfriend, whose name I have forgotten because I'm kind of stressed out, but I'm sure she'll tell us.
It's Megan.
Megan, thank you very much. And we are going to talk about something tonight that everyone knows what it is, though nobody's actually heard of it. But to me, it is one of the scariest damn things that has ever existed on this planet. Now, what am I talking about? I'm talking about a little thing called a prion. And I know you're asking yourself already, what's a prion? I've never heard of that. I don't know what it is. But what I do know is that every person listening has heard of a little thing called mad cow disease. So that's where we're going to pick up. So in 1986, cattle in Britain start to suffer symptoms similar to a condition previously seen in sheep called scrapie. And scrapie was a disease where the sheep would literally scrape themselves against fence posts. They seemed constantly itchy. They would fall down. They would chew at their feet. And nobody really knew what it was. But due to the behavior of these sick cows and the behavior that they explored, it was quickly nicknamed mad cow disease. Now, by 1988, approximately 420 cattle had been diagnosed as having what was called BSE, or bovine spongiform encephalitis. Now, it's called spongiform because the disease that causes this basically turns your brain into a sponge. It becomes a mass full of holes. It interrupts most of your abilities to think, to walk, to interact with other creatures, whether it be human or animal. And basically turns you into a sputtering mass of useless animal. Now, the people in Britain, they had a little bit of foresight, and by 1989, they had banned the consumption of certain organ meats, including the brain and spinal cord, having figured out that whatever this disease might be, it seemed concentrated in both the brain and the spinal cord, anything that had to do with the central nervous system. Around the same time, the United States banned the import of many live animals from any country where any BSE was known to exist. Now, by the early 1990s, as any good government would do, the British government began insisting that the disease posed no threat to humans, with an advisory committee on the subject calling cattle a dead-end host. And what a dead-end host is an animal, a person, a plant that hosts a disease, but from there it can't be passed on. It's not transmissible. It would not go any farther than that host. However, soon after this, house cats soon began dying in England, as a lot of their foods contained beef byproducts, and then several types of captive animals, also fed beef byproducts by zookeepers, began to die of what was then known as a TSE, or a transmissible spongiform encephalitis. Throughout all this, the British government maintained that the British beef was perfectly safe and the BSE posed no threats to humans. Now, by 1993, roughly 120,000 cattle in Britain had been diagnosed with this BSE. And people were starting to worry. The British government was starting to worry. And as the mid-1990s approached, Britain finally banned the feeding of meat and bone meal of other animals to animals, and also banned its use as a fertilizer. Furthermore, they began tracking individual animals and testing any cow over 30 months of age intended for human consumption. The goal here, trying to figure out where these animals were going and trying to track any diseases that might arise out of this. Now, fast forward just a little bit to August of 1994, where a young gentleman named Stephen Churchill, driving down the road in his mom's Ford Fiesta, crosses the center line and crashes head-on into another car. Now, both he and his passengers survived, despite the car being a complete write-off. But a mere 10 months later, Stephen was dead. So, though slowly losing his coordination and even the ability to write his name, his doctors had written this off as a slow-setting depression. After his family demanded another consultation, the doctors at the time were hesitant for a long time, to make a diagnosis that they thought would make medical history. Reluctantly, on February 13th of 1995, they finally did. On May 21st of 1995, just a few short months later, Stephen became the first and the youngest Brit to die of a new version of what is called CJD, Creutzfeldt-Jakob disease. Later named VCJD, variant Creutzfeldt-Jakob disease, or basically human mad cow disease. So in March of 1996, the British Health Secretary announces to the British House of Commons that mad cow disease is the most likely explanation at present for 10 cases of CJD, and that's again Creutzfeldt-Jakob disease, in people under 42. Now, the big problem here with this is that at the time, CJD was well known, but it was well known to be in people that were at the age of 50 to 60 plus. Now, there's some debate over whether that was due to the incubation period of the normal CJD or the exposure, and people were still kind of debating back and forth whether it was incubation or exposure that was the leading cause of it being mainly in people over 50 or 60. They generally did not see this in young people. This was the first time that the British government really admits that BSE could be transmitted to humans in the variant form of CJD. At this point, the government decided to take drastic measures, and 4.5 million cattle are destroyed. Shortly thereafter, Japan banned the import of meat and bone animal feed from Britain, and the European Union announced a ban on British beef and beef products. Now, at this time, the export of beef and beef byproducts was a huge part of the British economy. And you can deep dive this, and you can see the impacts that this had on everything from buying a steak at your local grocery store to the economic impact that it had on big companies like McDonald's, for example. McDonald's got a lot of its beef from Britain at the time, and they ceased doing that. So there was a time in the mid and late 90s where it was difficult to get a Big Mac because there was no beef. And once they had to transition over to American beef, there was still this kind of scare. I mean, and I was alive at this time. I can remember not wanting to go to McDonald's because what was I going to walk away with if I went to McDonald's? As we get into August of 1996, Britain's agricultural ministry finally confirms that mad cow disease can be passed from cow to calf. Now, so what does that mean? That means that it basically becomes genetic. A calf born to a cow with a BSE is likely going to have a BSE. And that was significant because they knew that now it became transitory. It wasn't cancer. You know, a mother with cancer does not give birth to a child with cancer. That's not the way that it works. And as much as they knew about TSEs and the BSE at the time, there was still a lot of debate about what it actually was, how it was transmitted, who could get it, what the actual symptoms were, and how it could be properly diagnosed. So shortly thereafter, a British coroner rules that Peter Hall, a 20-year-old vegetarian who died of VCJD, contracted it from eating beef burgers as a child. So for him, he got this disease somewhere between 10 and 15 years before he died of it. The substantial thing here is this verdict was the first to legally link a human death to mad cow disease. The previous death was not legally linked for several years until after it happened. The other astonishing thing is because of what was happening to the counties and the various cities that relied heavily on agriculture, the suicide rates amongst British farmers spiked, with some estimating that 3 British farmers were killing themselves each week. And it was partly because they were losing their livelihood, and it was partly over, if you do the research, partly over guilt that they thought that they were spreading the disease to the rest of the population. I find that statistic wild. To think that people that are of the earth and are for helping people are killing themselves because they're harming the rest of their populace. Kind of makes your heart stop a little bit. As of July 1997, 21 VCJD victims in Britain had been confirmed, with many more unconfirmed cases. So between then and 1999, there's a lot of things that happen. There's a lot of bans. There's a lot of don't send this here, don't send it there. We're not going to use it. Put it on the fire and burn it. But after a long and many exhaustive efforts, in August of 1999, the export ban on British beef is finally lifted. However, shortly after that, going from June 2000 to about May 2003, there are outbreaks in Japan. There are cases of VCJD in the United States, and it was a British woman living in Florida. You've got a Canadian man who dies from it after contracting the disease in Britain. And then we've got many animals, several cows, several bulls, several other wild animals in a number of states testing positive for the BSE version of this. And that's the big difference here is the BSE is the animal version and the VCJD is the human version. But we still have this continuous tracking of animals and continuous tracking of people, and we have both animals and people that are still continuing to get this. So going forward another couple of years, we have probably the biggest thing is that in December 30th of 2003, the USDA bans sick and injured so-called downer cattle from the human food supply, as well as risk materials and tissues such as brain and spinal cord. Now, why this is important is that there was a period of time where if you got a steak or you got a tube or a package of hamburger, it might have been from what's called a downer cow. And a downer cow is something that is either lame or is sick somehow. And assuming that they can give it one of the FDA approved tests and it doesn't test positive for any of those things, they can grind it up and use it as food. The hard part is at the time, there was no real test for the BSE. The only true test for it is testing a brain sample post-mortem. That's the only true way to show that an animal has that. Now, sadly enough, for a human being, it's also the only way to test to see if a human being has it, is post-mortem. So for all the people that have these things, if you think about the numbers, they're not actually that substantial. And we'll get to the final number from this initial outbreak in a minute. But as of January 2004, there's been 143 people in Britain that have been affected with VCJD, and over 180,000 cattle that have been diagnosed with the BSE. So then over the next few years, you've got lots of USDA announcements. We're going to be doing testing. Oh, we found another case here. We found another case there. And at this point, it's been found in just about every state that has any kind of either cattle import or cattle processing. It's been found. Going all the way through December of 2012 is when the USDA really establishes these hardcore rules for requiring livestock traveling across state lines to be tagged for traceability, and that there's some cattle under 18 months are exempt, as well as some chicks that are moved across. But this is when they really brought the hammer down. And theoretically, we kind of saw the proverbial end of BSE when it comes to seeing it in the news, and we see how people are affected by it. So the future, what does the future look like? Well, the original outbreak of VCJD, God, how many times am I going to screw that up? Of the variant, we'll call it the variant just to save my blathering mouth from trouble. What was found out is that it only affected individuals with a particular genetic makeup. And there are what we'll call the M form and the V form of a really long word that's hard to pronounce. Studies of similar diseases in other parts of the world show that people with the M form tend to become ill quickly in the first wave, where individuals with the V form can be infected but asymptomatic for years or even decades. This basically led researchers to basically conclude and to warn that there could be a second wave years later. And then late in 2014, they had the first case reported of an individual that had both forms. Um, and that was important because now we know that there's a middle ground. It isn't going to be someone who's going to get it right away, and it's not going to be someone who's going to get it in 30 years. There's kind of a middle road. So to wrap up our Britain's gone wild with mad cow disease, as of August of 2023, 178 people had contracted and died of the variant of the disease. So that doesn't sound like a lot, right? It doesn't sound like a lot, 178 people. I mean, you look at things like COVID, and there was millions of people that died. So it doesn't seem like it's really that kind of big deal, you know? But then we talk about diseases like COVID, where we take all these precautions and we have all these restrictions. And the reality is, with something like a TSE, a transmissible spongiform encephalitis, there's a mountain of different versions of it. And B, you very likely have some form of it in you right now. Just because you are alive, you have lived, you've touched things, you've eaten things, you've eaten plants. I mean, it's been proven, and there's an interesting anecdote later that these are transmissible via plants, and nobody thought that was possible. So as we dive farther into this subject, and I think this is maybe the reason that I find it so crazy, is that this is just something that gets into you through one way or another, depending on your genetic makeup. It will either leave alone or attack a certain kind of protein in your body that's already there. And the prion protein, or the PRP, as it's referred, is basically existent in everyone. It's just, do you end up with this little tiny bit of matter that is technically not alive, but still somehow able to replicate itself? And does it wreak havoc on you? And if it does wreak havoc, does it do it in a year, or does it do it in 50? And that's a big piece of what scares me, because it could be wreaking havoc on me right now, and I have no idea. We'll see tomorrow. If I remember recording this podcast, maybe I'm okay. Maybe not.
Well, is this possibly something that's like, would you see this as like an organism that actually, I mean, can you even call it an organism? It's a protein basically, right?
Yeah.
Correct. You can't call it an organism because it has no nucleic acids.
Yeah. So it's like, gosh, I mean, it feels like it's a world ender if it wanted to be, or like a genetic fault, or like I don't know what you would call it, like a cataclysmic fault. Like, is it possible that genetics got to a point where it's like, oh, they created this and now it's just destroying, like it destroys itself basically. So like this is like a DNA eraser.
It's
So
like the black goo in Prometheus.
In a sense, it is, because you never know what it's going to do to a certain individual.
Yeah.
And that is the crazy part of a prion. As I said, you could get a prion. Everybody here could get the same prion, and it might do nothing to any of us.
Mm.
But given your
Yeah.
your genetic makeup, given your exposure to other prions in the past, it might. Everything that I've researched, and let's be clear here, I am not a doctor, and nor am I giving medical advice, but everything that I've read, the research that I've done, says that all one of these prions needs is another prion to make more of itself. That's all it needs. And they form chains, and those chains form a chain reaction. Now, what exactly does that look like? Like, I can tell you what it looks like. Another example of a prion-like disease is Alzheimer's. Alzheimer's is a prion-like disease. And what does Alzheimer's do over time? It builds up plaque in your brain that slowly drills holes in your brain and makes your brain tissue be destroyed. These TSEs are very much the same thing. Alzheimer's is described as a prion-like disease. Parkinson's is very similar. It's it's a disease that destroys neurological tissue. Now, Parkinson's and Alzheimer's do it a little bit differently, but in the end, it still becomes a misfolded protein that results in the buildup of these plaques. That's what it is. And these plaques take the place of your living, functioning brain tissue. For me, uh, I think I've discussed a little bit about why I find this fascinating. And I've got a history of proteins here where we talk about somewhere where some of this stuff came from, and it
Also, I'm sorry, Brent, but also it was just reminded me of something. Isn't Kuru also a part of
yes, yes,
prion disease, right?
we will talk about Kuru at length
Right.
because
I'm sure.
Kuru is one of the more, call it, modern but also sort of amazing examples of a TSE,
Mhm.
and how it can not necessarily be passed through an animal and our consumptions of animals, but it can be passed through a cultural process.
Mhm.
So we will definitely talk about that. So like I said, I was going to talk about the history of proteins because proteins is a big piece of where prions kind of come from and where a lot of their discovery came from. As I'm reading over it here, it's honestly kind of boring and is not filled with a lot of good information. It's nothing that's going to be super new. Um, but I do have a lot of, we'll call it quotes slash anecdotes about what prions are. Um, and to be honest, I copied them all down because they're all fascinating in one way or the other. They all have something either very scientific and groundbreaking to say, or things that are rooted in a lot of, we'll call it, phrases and words that most people can understand that sort of scare you a little bit. Um, so I think we'll go there, and then we will get on to the history of the prion, and then we will get on into the prion diseases, because that's where we're going to have some real fun. So quotes on prions, some of the best. So a prion is a biological anomaly, self-replicating, not alive, small particle that can misfold into an unstoppable juggernaut of a fatal disease. Prions don't contain genes, which is the key here, and yet they make more of themselves. This is for scientists to rethink the central dogma of molecular biology, that biological information is always passed on through genes. For me, science class, biology class, doesn't matter where you were. You grew up talking about DNA, and that every single living thing had DNA, and that's how it made more of itself, all the way down to the simplest amoeba. It had a collection of intellectual cells in itself, and that was what gave it the ability to reproduce itself. The prion has none of that, and yet it is able to reproduce itself.
This is a fascinating thing for me, and I just want to interrupt you for 1 second because
Yes.
of the fact that I'm actually, like I said, writing a book similar to this. Seth knows about what in the separation between actually genetic mutation versus prions being able to actually fold over on themselves. Like that is amazing to me because it seems like they could not only do harm, but they could do help if it were to be in the right organism. Do you think it could actually fold itself and actually make something like better or make it something more impermeable to some kind of harm from external factors or conditions?
Well, we'll get a little deeper into the science behind a prion, but for the longest time, most research has been based on just trying to figure out how a prion does what it does. There's still a lot of misnomer and misconception. The best thing that I have found is that a prion is able to exist and able to basically discombobulate its 3D shape and fold over on itself taking a neighboring protein with it. And once it does that, once it goes from PRP, which is a prion protein, a normal thing, into something like a PRPSC or a PRPN, once it does that, it's basically able to explode in replication, taking any protein that it encounters with it. Now, proteins, as they exist, they're basically on the surface membrane of every single cell. Every single cell has got a protein in it that is a contributing factor most of the time to the cell's health and the cell's ability to regenerate itself. Now, when a prion comes in and it starts to steal those, and it starts to build these big balls of plaque, it just continues to spread because every cell is effectively food for it. Even though it's not actually using the cell as food, it's taking the proteins, building these plaques, and pushing out and killing all of the healthy tissue. That's what it does. Now, could it be used long term for something that's good? I did see one article that talked about using a prion as a warrior against things like cancer, where you could take a cancer and use a prion to basically eat away at the cancer and basically not kill the cancer, but isolate the cancer from expanding.
Yeah.
Putting it in a place where it's basically bubbled and it can't expand anymore. Basically cutting off its supply of healthy tissue to complete its cycle of malignancy. Now, at this point, it's theoretical. No one's actually tried it. Reading all what I know about this, there's a reason. But
It's like it seems like controlled burning. You know what I mean? Like you're gonna,
it
you
seems like
burn,
seems like a
you
good idea
burn-
until the wind comes up. You mean?
Oh yeah, exactly. Controlled burning. You burn a place so that a fire can't expand.
Correct. Yep. Yeah, and it's like I said, it's a great idea until the wind comes up, and then
Yeah.
everything just absolutely goes to hell. So dropping down one more time down our list here, I've got a couple more of these things, and they're again to me still fascinating. So I think they bear talking about. Now prions are an unprecedented infectious pathogen that cause a group of invariably fatal neurodegenerative diseases by an entirely novel mechanism. Now, in science, it's pretty rare to hear an entirely novel mechanism. Generally speaking, down to the smallest amino acid and things like that, we have got a fairly good understanding of how things work. Now, I understand we're learning things new every single day, but people have been studying prions in depth, looking at them since the 1920s, and they're still not even sure how they replicate. They have a good idea, but they're not entirely sure, and no one's ever been able to get them to replicate in a lab. They've never been able to do it. They've been able to isolate them as the pathogen that they are, but no one's ever gotten them to replicate. It's not like a virus where you put it on a growth medium and it grows more virus. No one's ever gotten them to do that in a lab. In the human brain, obviously, they've gotten to do it, but again, nobody's ever able to prove that until you're dead and your brain is in a pan and someone's picking it apart. So prion diseases may present as genetic, and again, that's the cow to calf. Infectious, that's our variant, Creutzfeldt-Jakob disease, or sporadic. The sporadic is probably the wildest of all of these because it basically encompasses the prior two, but then also puts a mystery into it. Sporadic could be, I ate a piece of meat. It could be, my grandfather had this and passed it down. My dad didn't get it, but I did. Or back to I went to the family barbecue and I had a piece of that great jerky, and 18 months later, I'm dead. So it's crazy that, and it kind of explains why people are so hard pressed to bring it out in the open and to reduce it to its baser thing, is because it's a wild card. It doesn't often do what people think it's going to do. Even when they isolate it in a lab and try to make more of it, it won't do it. It just won't. And nobody has really understood why. It doesn't make any sense. So the basis of this is that it all involves a modification of what's called the prion protein. That's the PRP that I've talked about. PRP is a normal thing. Everybody's got PRP within their system. It's the matter of the introduction of another prion that has modified itself or folded itself or discombobulated its 3D shape that makes the prions sort of, for lack of a better term, kind of go off the rails and continue to do their multiplication. Now, it's still odd that we have this object of matter that has no nucleic acid, it has no building blocks of life, but it's still able to replicate itself. That to me is probably the craziest thing, because when you have something like that, there's no way to vaccine for it. There's no antibiotics you can take. There's no treatment for any transmissible spongiform encephalitis. They are 100% fatal every single time. Any kind of care that you would give to somebody that has one of these is supportive. That's all it is. We're waiting for you to die. There is no curing this. And a piece of that is the lack of understanding. Again, insane to me, but that's just me kind of drilling over this, and I just think it's super awesome.
What is the what's the connection, if there is any, between this and like rabies? Because rabies is also a protein based disease. It also has a 100, basically a 100%. There's only been like 5 cases of anybody ever surviving rabies in the history of everybody. So,
Well, but I mean, fundamentally, rabies is identifiable. Rabies is not a self-replicating thing. It has to be in your body. It has to have a host to replicate. And it's one of those things where there actually are treatments for rabies. Now, to your point, people that got full-blown rabies, yeah, there's a handful of people in the history of time that have survived. But people that have been bitten by a rabid animal and been given a very painful series of shots in their stomach can be rid of rabies.
before symptoms manifest, you can be saved. But once symptoms manifest, yes, you're
correct.
you're
Yeah. As I understand rabies, rabies is a virus, and like anything else, if you understand it enough, you can kill a virus. You can kill it. Whereas a prion,
oh yeah,
it's
gotcha.
not living. It's not living. So how do you kill something that's in your body that's not alive?
So it seems, is it like rogue instructions? Like, obviously, is it like, I don't know, I've heard a whole bunch of theories on like the early virus class, but it's almost like it's this whole other thing without like a core set of instructions, but it's like almost like a roll of the dice of proteins that may or may not interact with something. Does that
Well, to be honest, because even now proteins are very poorly understood, like the function of what a protein does in your body. I've seen quotes that said that you could go through your human body and remove most of the proteins and it would not have a catastrophic effect on the body. So when you have something like that everybody knows plays a part in things, but they don't understand the exact nature and how the action of a protein correlates to the action of any given cell or any given type of cell or any type of cell structure, that makes it that much harder to understand the function of the small, basically inert, not alive little particle called a prion affects that protein.
Okay. And is there, and you may be getting into this, but how sophisticated is the screening in terms of the food supply?
Okay, so in most countries now, we've got, I'm going to call it the most basic of protocols. So a lot of the things that you see today, as far as tracking of animals, where one cow goes from one place to another, if you go to your local store and you buy a steak, by information on the label and information maintained by the store that did the butchering. You should, in theory, be able to trace that steak back to the farm the cow came from. Okay, you should, in theory, be able to do that. Now, that seems like a lot, but at the same time, a lot of it makes sense to me. Traceability, especially with the food supply, is a big deal. Most of that comes from mad cow disease. Before that, the beef that showed up there, most people would tell you that it came on the beef truck. That's where it came from. And beyond that, nobody can tell you where it came from. Now, could you do some digging? Could you look at some purchase orders and look at some transit orders and do some this, that, and the other thing? But most of that, when it comes down to a side of beef, it's got a number on it. And that number can be tracked all the way back to the farm that it came from. So you will know the farm that it came from, what that cow ate, when it was slaughtered, everything. But all of those precautions and all that accountability comes from mad cow disease.
So it's all like, so you're saying the protocols are basically like, oh, we found some, and the only thing they can do is trace it. So there's not like a color swab. The ink turned pink, so that means it's got whatever. It's not like that.
As I understand it now, every cow that is slaughtered is tested for this.
Okay.
And again, the only way to test for it is actually, from my research, there's no pregnancy test for a prion. There's no pink or blue kind of thing.
Yeah.
It is a visual inspection of a microscopic slide of brain tissue. That's what it is. And these prions, and moreover, the plaques they leave behind are, when you see them on a slide, they're very obvious. And so people now, I think, are trained to see these things. So it is screened for. How often it's screened for, how many samples they take from one cow, I couldn't tell you. I don't work for the USDA or for any of the slaughters, but I know that it is tested for. How often does it come up? Oddly enough, that's the one thing I could not find any information on. How often are things actually testing positive? I could not find any public information on that.
And you're saying like test positive, then they destroy it. You wouldn't know.
Correct. I don't have a number. Is it 1 in 10 cows, 1 in 10,000 cows, 1 in a million cows? I don't know because I could not find a number.
We definitely should not have eaten a burger before this.
Well, on the bright side, if you're not a fan, you'll probably never eat one again. So
I was vegetarian for 4 years until this year, and thank Seth for that.
I was gonna say that's looking pretty good right now, isn't it? So to our last definition of a prion, or one of our last couple, and this one actually has some good information in it, which is why I think it's appropriate. And I don't think a lot of it's new, but I think the phrasing is new, and it kind of tells you a little bit about it. So a prion is an illness-inducing misfolded protein. Depending on how it's misfolded, the prion may also become infectious, and they often do. Oddly enough, all known prion diseases but one are caused by changes to a single mammalian protein, the somewhat confusing name prion protein. This protein, in its healthy, properly folded state, is, if not trivial, relatively unimportant. Its complete loss would not be catastrophic to a system. So we have this. It's there. If we expunged it from our system, we'd be okay. At the same time, it's responsible for one of these numerous diseases if a certain set of criteria are met. So yet, in a highly unfortunate accident of nature, this protein stirs up an extraordinary amount of trouble when broken. When mutated and misfolded in one of 34 known ways, 34 different disease-inducing ways, it becomes prion proper. When a prion bumps into a normal prion protein, the prion protein shape metamorphoses into the disease form. Like a zombie, now it can create more prions. So you guys know me as Grindhouse Zombie. That statement right there just makes all my hair stand up. I mean, it's the things that shouldn't happen, but still do, and the understanding is not complete. Those are the things that scare me. cancer doesn't scare me because I know why cancer happens. It happens for a number of reasons, including certain bad habits. But it is what it is. This is something that you ultimately have zero control over. It may or it may not happen, again, depending on your genetic makeup. And if it does happen, you'll probably never know it unless you have an autopsy, and by then you're probably beyond caring. But it could also look like something else, which I think is even more scary to me. Okay, so getting past the definition of what a prion is the idea that a protein alone could transmit a disease. Now, this idea has been around since the 60s, but ever since then, there's been a lot of evidence stacking up to support this idea. So now Stanley Prusiner, I think I'm pronouncing that right, or Prusiner, he's the one that coined the term prion, and he actually pronounces it prion, in 1982. And he's the one that showed that purified prions can transmit spongiform diseases. And people have been trying to prove him wrong ever since. The idea that a protein can reproduce itself without going through a nucleic acid intermediate goes against everything that we know about transmissible diseases. Because even the simplest viruses contain genetic material, DNA, RNA, or codes for the protein necessary for function and transmission. So because prions appear to be infectious proteins that can self-replicate, this goes back to the central dogma of molecular biology, and the fact that it doesn't seem to apply here. Ultimately, there's a lot of scientists, researchers, and things that have a lot of reservations and are very skeptical about how a protein-only hypothesis can actually work. Now, the biggest header here is you can't kill what isn't alive. The prions themselves cannot be destroyed by boiling, alcohol, acid, standard autoclaving methods, or radiation. In fact, infected brains that have been sitting in formaldehyde for decades can still transmit spongiform disease. Cooking your burger till it's well done is not going to destroy the prions if they're present.
See, that's what's crazy to me. Proteins like change fundamentally when heat's introduced. That's what's so nuts. Acid, boiling, alcohol. That's so insane.
I also have a question too.
Go, Clark.
Why does it attack strictly the brain? Like, why does it not attack any other muscle or any other fatty kind of like tissue at all in the body? I mean,
well, specifically anything that's basically a TSE level disease and the whole transmissible spongiform encephalitis. Well, we know what encephalitis is, right? Encephalitis is basically swelling of the brain, right?
swelling of the brain, that's what it is.
So that's where the whole family of diseases has come from. It's basically exactly, that's where it was born from. So that isn't to say that these prions can't exist in other parts of the body, and they often do. What it boils down to is the largest collection of these things tend to be in the brain and the brain stem. That's where the largest collection of these tend to be. So that's where you see the largest impact and the largest, the amyloid plaques, and where those build up. That's why you see the largest impact there. Now,
them also building up in the brain stem. I would be like, I'm kind of shocked there's not more cases of like sudden death because of just shutting down nervous systems.
Well, okay, so that's one of the beautiful things of prions. And again, it depends on your genetic makeup. And upon exposure, you may have, again, nothing happen. You may have a slow form of it where it gets you, use the first guy in Britain to die of it. The start of his symptoms was roughly 18 months before he died. And then you have people that, and we'll talk about it when we talk about Kuru, that were infected 50 years prior and didn't show symptoms for 50 years. And then got the symptoms of this. And then the one common thing that I see is generally when symptoms start, within 12 to 18 months, you're dead. So Exposure is often hard to track. Using Kuru is probably the best example of tracking of exposure because they went in there and said, stop doing this. This is why your people are dying. Stop it. And they said, okay, we stopped. And they continued to have cases sporadically. Then they went away. And then they had another slew of cases. And then it seemed to go away completely. And again, with the genetic makeup, you might get it now, you might get it never, or you might get it way down the road. And that to me is one of the coolest things about this, is that your genetic makeup is the piece that tells the tale about your future. And your future might be bright. It might be tomorrow, or it might be 50 years from now. And that's one of the things that I love about the Prion, and what it did, and also why it scares the hell out of me.
I was watching this movie a long time ago, and the movie opened up in this icy area, like in Nebraska, and it was like this woman that was rolling her groceries, and then she suddenly fell over and was like bleeding and had like some kind of crazy death out of nowhere. She was an older woman. Later on, there was the husband. And then throughout the whole movie, I don't even know what movie it was. I can't even remember the name. But they were basically they were cannibals, and they were in this small like weird group of people that continued some old practice, and but they were all dying from this, and that was the movie. But the way it opened up was so eerie. Like everybody was like dropping dead, and the authorities were trying to figure out what was going on. But I think the thing that's most disturbing is like there's no way to destroy. I mean, I guess they have better screening, like you said, with the brain slide, the slides of the brain samples. But I would hope that happens with every single cow. If you could picture every single cow that's slaughtered in the United States, and man, that's just scary if somebody starts slacking off.
I'm just saying, how do they even start tracking that? There's a lot.
There's a lot.
So knowing what I know, and with all the research that I've done, I will jump to this part because we're talking about it. So within the human body or the animal body, there is no way to destroy a prion. And prior to about 4 years ago, the only human remains that were deemed safe to touch were remains that had been cremated, and cremated by a licensed crematorium at 900 to 1100 degrees Fahrenheit. Now that said, the World Health Organization has put out some new guidelines when it comes to sterilizing, especially surgical instruments, when it comes to something like a prion. Now there's a 3-step process, and it's crazy as hell, but it basically is immersing things in sodium hydroxide, then putting them in an autoclave at 121 C for 30 minutes, and then after that, perform routine sterilization processes. Then you're probably okay. There's also immersion in sodium hypochlorite for an hour. Gravity displacement autoclave again at 121 C for 1 hour, then routine sterilization. Then there's the third, which is sodium hydroxide and a combination of sodium hypochlorite for 1 hour, transfer to an open pan, and then do the gravity displacement at 121 C, or in a porous load, which basically means a higher temperature but open autoclave for an hour, then perform routine sterilization after that. So this is just your average scalpel or your average pair of forceps that you have to take.
Or neurosurgery on a person.
Exactly.
That's why I want to like make sure everybody is understanding. Like,
yes.
I don't think it was actually put out there. This is neurosurgery. This is what they have to go through to actually make sure.
Correct.
Wait.
Yeah.
Are you saying even if that, like, no matter if they get a cadaver or anything, like, it doesn't matter. Those surgical instruments, even if it's just random Joe out there just needs to get something fixed in his head, they still
An
do this.
aneurysm, like something
Anything.
like a blood clot, something.
Wow.
Yeah. So up until my research says that up until about 4 or 5 years ago, there was no sure method. And now today, this is what the World Health Organization recommends. So you're basically taking your stainless surgical instruments and you're boiling them in acid for anywhere from 30 minutes to an hour. And then when you're done with that, then you follow standard sterilization requirements in an autoclave. So that's what they're deeming safe and effective now. So,
Wow.
I mean, think about, and I would honestly hope that most things that are surgical, I mean, like I've had my spinal cord opened up to the world 2 different times for 2 different things. I hope to God somebody cleaned those. I mean, because it scares the hell out of me that, again, to me, it goes along with I've eaten deer my whole life. I think I've told you guys my dad died of Alzheimer's, and I always wonder, did he eat a deer at some point in the past? And so, but it makes me wonder. So, this to me is probably one of the scariest things that you could deep dive and think about. The deep dive that I've done on this would give you nightmares. It would give you nightmares.
Well, the Coursefield Jacob stuff, which obviously is an extension of all this, it was a big thing in the last couple of years where, for me personally, I was like, oh man, so we started seeing some of the southern deer. It was Texas. It started in Texas, started moving east, where they started seeing actual, recorded cases of that. And I was like, oh, okay. And when it started moving, more and more east, I was like, okay, well, we eat a lot of deer here,
Same here.
in Georgia. And so I was like, oh, well, if they're seeing it in Texas, it's only going to be a matter of time for migrates this way. So yeah, I mean, it's getting a little scarier and scarier now. So,
Well, put it in these simple terms. So I came down here tonight to polish off my notes, and they're still not super organized. I was just a little anxious about this. But I grabbed a Mountain Dew to give myself a little caffeine, grabbed all my other stuff, and just out of habit, I needed a snack. I grabbed a bag out of the fridge and brought it down here. So I'm drinking my Mountain Dew and I'm typing on my notes and I'm snacking, and I realized that I'm eating the deer jerky that I just smoked a few weeks ago. And I was like, ah. And I put it down, ziplocked the bag, and put it back in the fridge. I'm like, not today. Today is not the day for this. But it is that simple. And I think the reality of how close all of us are, it's kind of scary. Like really how close you actually could be to this. Now, is it going to happen to you? I think it sort of depends. It depends on your genetics. It depends on your lifestyle. It depends on how well you sterilize your surgical instruments. But if you're with a certain tribe in a certain country, it also depends on your funerary processes. Okay, so we're going to do a little bit of a brief history of prions because it kind of fills in the gaps, but the closest modern day experience that is not mad cow disease is Kuru, and Kuru is so interesting that it really can't be ignored. So we're going to do a little bit of a history, and then we will get right to that. So initially, my research was talking about the 18th and the 19th century, and then as I dug a little deeper, it was basically the 1730s that exportation of sheep from Spain. A lot of the sheep, they were observed to have a disease that ended up being called scrapie. And we did talk about that a little earlier. And it caused the animals to scrape up against things, to be constantly rubbing on like fence posts from pens, but basically to lie down, bite at their feet, rub their backs against posts, fail to thrive, stop feeding, and finally become lame. Now, the disease was also observed to have a long incubation period that is a key characteristic of any TSE, and again, that's a transmissible spongiform encephalitis. And although the cause of scrapie was not known back at the time, it's likely the first recorded instance of a TSE. Now, fast forward into the 1950s, and there was a lot of things that happened in between the 1730s and now, but a lot of it is anecdotal. The 1730s thing was just kind of the first instance of people recording what they saw. After that, there was a lot more people recording what they saw, but a lot of it was not super prominent, really, until you get to the 1920s and we start talking about people exploring TSEs. But it's a lot of early history research, and honestly, a lot of it's kind of boring. But getting into the 50s is when we start talking about Kuru. Now, Kuru is honestly nothing short of just kind of wild. So we're going to kind of go through it. And I know, Ro, you had asked about this, so we're going to give it its due, because it's honestly one of the cooler, call it TSEs, if there is such a thing as a cool TSE. Maybe there's not.
Absolutely. I agree, Brent.
Oh, well, excellent. And if you have anything to add, you feel free. Okay. Okay, so Kuru is now known to be a TSE, but it's described as a rare, incurable, and fatal neurodegenerative disorder that was formerly common amongst the Fori people of Papua New Guinea. Now, it's a TSE, that's the folded protein, and it leads to symptoms like the tremors and the loss of coordination. Now, the term Kuru derives from the Fori word for kuria or guria, which means to shake, and that was described by the tremors that people got. That was a classic symptom of the disease. Kuru itself means trembling, but it's also known as the laughing sickness due to the pathological bursts of laughter, which are a symptom of the disease, and that's part of the neuro breakdown that people succumb to. It's now widely accepted that Kuru was transmitted amongst members of a Fori tribe, Papua New Guinea, due to funerary cannibalism. Now, deceased members would traditionally cooked and eaten, which was thought to help free the spirit of the dead. Women and children usually consume the brain, the organ in which infectious prions were most concentrated, thus allowing for transmission of Kuru. The disease was therefore more prevalent among women and children. The epidemic likely started when a villager developed sporadic, and there's that sporadic again, that word that we don't know where it came from exactly, but one person got it. It was random, but because of a practice of the people or the village, it literally turned into something else. So when a villager developed sporadic Creutzfeldt-Jakob disease and died, when the villagers ate the brain, they contracted the disease and spread it to the other villagers who ate their infected brains. So it got passed down and passed out and passed down. So while the Fori people stopped consuming human meat in the early 1960s, when it was first speculated to be transmitted via endocannibalism, the disease lingered due to Kuru's long incubation period, anywhere from 10 to over 50 years. The epidemic finally declined sharply after half a century, from 200 deaths per year in 1957 to no deaths from at least 2010 onwards, with a few sources disagreeing on whether the last Kuru victim died in 2005 or 2009. So a disease observed in the 50s, because of a practice of the culture, carried forward into 14 years ago. People died of this. It's the custom itself, I think, for me personally, as a Midwestern white guy, is crazy. I mean, funerary cannibalism, wow. But at the same time, it's like, I love the fact that there was a group of people somewhere that thought that much of their dead that they did that. I think that's the part of me that thinks that's really awesome. This is how I honor your spirit and your life. I consume you. I think that's awesome. But talking about our friend the Prion, a lot of the research that I have points to this specifically, Kuru, and talks about how amazing that it is that they had this isolated group of which they could do so much research. And because of the size of the group and because they were able to come in there and affect change on the group, they were able to continue to study it for years and years and years and ultimately say, yes, this practice caused it. The cessation of this practice will end it at some point. And now, theoretically, this tribe in Papua New Guinea has gone close to 15 years without having a death from this disease because they ceased this practice. And not because somebody told them that eating the brains of the dead makes you a devil worshiper or whatever it was, but because there's a pathogen that you're spreading, and you should stop doing it. And going forward, it will keep your tribe healthy and vibrant and growing. And that whole thing to me is just absolutely incredible. You have any other comments on Kuru, Ro? And would you like to know any more? Because I do have more.
No, I think you pretty much covered it, but I also wanted to know whether you guys know about Aghoris, the Aghori tribe in India.
No.
No? Right. So, these tribes, the Aghori tribe is known to eat human dead bodies. I mean, they don't kill humans, but rather they feed off dead bodies that they find in the sea or and you know that in Hinduism we cremate our bodies, we don't bury our bodies. So it is supposed to be in a way, if an Aghori man comes and eats a part of your dead body, is supposed to be a good thing, which means that the person will go to heaven. Um, so, but I haven't really heard about Kuru in them, strangely. Or maybe that is such a secluded tribe that no one's ever really tried to diagnose how they died. So yeah, that's something that probably we can look into later.
Or potentially eating heavy parts of the human body and not the brain.
Quite possible.
I once again don't know, but I'll go from a Western standpoint of this with Native American, like the Wendigo kind of mentality of like, if you consume enemy, you take their power. Like, the brain is not actually something you consume. It's actually more of the muscle tissue and the actual, kind of thing. It sounds morbid, but it's actually the better parts of the body. I hate to say it. And the brain is not really what they want. So,
well, and that's a valid. Oh, I'm sorry. Go ahead, Ron.
So it's not like they harm anyone or they don't steal, they don't incite violence. It's just that they undergo penance, and it's strangely, I mean, obviously, because their way of living is so different from us normal, and I say normal in quotes, us normal humans, that there are a lot of misconceptions around them, that they perform black magic and things like that. But when I say that, when the bodies go to the crematorium to be cremated, it's they eat the flesh of people, or whose family members have given them permission. So it's not like they just go and eat out of random dead bodies that have come, that have been brought there to be cremated. But yes, I have also heard some of them pulling bodies from the river Ganga to eat it, but I'm not really sure what is the truth in that? So um I there are and if I remember correctly, having conversations with the elders in my family, um the practice, as with other practices, the idea is to recognize a higher self or a state of being for them. So, and I kind of agree to what you said, Clark, that they do not necessarily consume the brain, but what they consume is what remains of the human navel after cremation. So, a lot of um, extremely opposing views. But yeah, the fact still remains that they do eat human flesh.
Well, yeah, like I said, the thing I'm saying with the Western thing is it's like it's consuming a power. It's like absorbing an energy.
Mhm.
So,
Yeah, and I'm pretty sure they don't eat it every day,
yeah,
and they don't eat it for fun.
not a normal thing, but that's the
Yeah,
it's the impetus, the idea behind it.
yeah.
Yeah.
Well, and ultimately, if it's cultural, I mean, that's like I don't personally find it abhorrent, but I think if you go into any culture, you can find an action that one other culture would find abhorrent, right? At
Hmm.
at, at the same time, I think with any culture, and you talked about people pulling, say, bodies out of rivers. I think with any culture, part of what is cultural also becomes subject to folklore and
Right.
and embellishment, and so maybe that's part of that. I think that always happens. That's not to say that there wasn't one guy that pulled a body out of a river and ate it because he was hungry. I mean, I'm not gonna, so I don't know. It's not something that I have enough knowledge in to be cogent on the point. But I don't see it as that far fetched either. So if
Well,
that's
that in that same culture, that's where we get in America, Skinwalker, Wendigo. That's where we get it's basically Western native vampirism. If you kind of want to, look at it that way, that's where that comes from.
Yeah. Well, totally off topic, but if anybody wants a good, call it Wendigo sort of folklore movie, The Lord of Misrule just came out today. I had an opportunity to see it early. It is fantastic. Go watch it. That's my big one. So we've covered Kuru, funerary cannibalism, which I think from a cultural aspect is in a lot of ways phenomenal. I kind of dig it. Um, I hope that doesn't say something bad about me, but I think it's kind of awesome. Um, do we have any more comments or questions on Kuru? Because if we don't, we're going to move on to another prion disease.
I didn't even know there was another. All right.
There are 33 more, Clark.
Oh, dear.
33. Speaking of deer, we're going to go on to chronic wasting disease, which is effectively a disease of the ruminants. And that's wild animals. That can be cattle, that can be a lot of different animals, elk, things like that. The reason that I think it's awesome, not awesome, interesting, is so I live in Minnesota and we have chronic wasting disease here. I know you guys have talked about it too. You have it in your areas. Um, I love the fact that it's often called the zombie deer disease. um, and it's called that because of its effect on the animal. Um, how it will have an incredible thirst, how it urinate all over itself and not have any idea where it is, how it will become lethargic, how it will stop interacting with the animals around it. And it basically walks around kind of in a daze, doesn't know what's going on. Eventually, it will stop consuming any kind of sustenance. It will lay down and just effectively die. Now, the scary part about that, and there's been a couple of different experiments performed on this. And if you have a grassy field and you have a deer that dies of chronic wasting disease, and it naturally decomposes into the ground, and then a couple of years pass, and we have a new herd of deer that come through and eat that grass, those deer are susceptible to getting chronic wasting disease from the plants that they eat. There's been several experiments performed on this, and it's actually a thing. Several different scientific communities took animals that had a TSE, let it naturally decompose in an enclosed area, took animals that showed no signs for their age, and usually by a certain age, if they're going to have it, they'll show signs. Put those animals into those pens, they ate the grass, and then within 12 to 24 months, developed a TSE and then later died of it. That I honestly think is maybe not something that the powers that be know about, because I know when we talk about chronic wasting disease here in Minnesota, they talk about it's usually among herds, and it's usually among herds of captive animals. And the scary part is they will find one animal that has it, they will cull the herd, call it good, and then the person that had the herd brings in more, never having understood that it might be in the grass. Another thing that scares the living hell out of me, and again, because I eat a lot of deer. So 2 months from now, guys, if I come on the Discord and I'm babbling incoherently, ask my wife to check on me. I would really, really appreciate that.
We'll do that.
Yeah, so chronic wasting disease, that's probably the biggest one amongst our wild animal friends. And there's been a lot of testing, a lot of genetic testing, a lot of guesses about how it's spread and the transmission of it. I think people are still learning a lot about it, but ultimately it's another one of those things where the diagnosis can only be done post-mortem. And I think I'm an animal lover. I like that, and I never. I appreciate the fact that we're always striving for the greater good, but there's also a little piece of me that it sort of breaks my heart to think of a herd of animals being killed because of a maybe. So I hope that better tests are developed that could be done, and so we're not just going out and culling herds of wild deer because one of them was walking funny. It just kind of unnerves me a little bit. So that I think is probably one of the big ones. We've talked about bovine spongiform encephalopathy or encephalitis. That's mad cow disease. We've talked about variant Creutzfeldt-Jakob disease. That's basically human mad cow disease. There's a few other forms that are interesting. We have scrapie. That's the sheep disease that people have witnessed and seen firsthand. I mean, from the 1730s. So that's been around forever. I think the one that probably freaks me out the most, and there's a couple of variants, but we'll cover the main one, is called fatal insomnia. So fatal insomnia, and I'm going to read this just because I don't want to read right through the Bible here or reinvent the wheel.
Before you start this, I gotta ask one question. Is this different from fatal familial insomnia, or is this the same thing?
Fatal familial insomnia is typically genetic, and that goes back to the transmissible, sporadic, or genetic, and how one of those is often an umbrella for the other ones because there's still a lot of unknowns.
I basically spoiler alerted everybody.
Kind of. Well, but just if you're patient, Clark, and I know you can be, we'll be there in a minute. Okay. So fatal insomnia is a rare, extremely rare neurodegenerative prion disease. Prion being the key word there, ladies and gentlemen. We've heard that again. That results in trouble sleeping as its hallmark symptom. Well, it doesn't sound that bad. I've had trouble sleeping. The majority of cases are familial. stemming from a mutation of the PRNP gene. So we've talked about PRP being the prion. The PRNP gene is that genetic predisposition to something. And that's a big thing with prions. And from all the research I've done, more and more, there's a pre-existing genetic predisposition to a lot of these things, which makes it even kind of scarier. So while the majority of cases are familiar, the remainder are sporadic. And there's that sporadic, and I think they use sporadic just because no one's done a 23andMe on that person and connected to somebody else. You know what I mean? So the problems of sleeping typically start out gradually and worsen over time. Eventually, the patient will succumb to total insomnia, most often leading to other symptoms such as speech problems, coordination problems, and dementia. It often results in death within a few months to a few years and has no known cure. Now, the disease has 4 main stages. The first is characterized by worsening insomnia, panic attacks, paranoia, and phobias. This stage generally lasts around 4 months. Stage 2 is hallucination and panic attacks that become very noticeable, and they continue for about 5 months. The third stage is the complete inability to sleep, followed by a rapid loss of weight. This lasts for about 3 months. The fourth stage is dementia, during which a person becomes unresponsive or mute over the course of 6 months. It's the final stage of the disease, and after which death follows. Now, clinically, fatal familial insomnia manifests with a disordered sleep-wake cycle, dysautonomia, motor disturbances, and neuropsychotic disorders. So you've got profuse sweating, pinpoint pupils, sudden entrance into menopause or impotence, depending on your sex, neck stiffness, elevation of blood pressure, and heart rate. The sporadic form, oddly enough, is often accompanied by double vision. Just to make matters worse, constipation is also common as well. So I can't sleep and I can't poop. I can't think of a worse world than that. I honestly can't. As the disease progresses, the person becomes stuck in a state of pre-sleep limbo, which is the state just before sleep in healthy individuals. During these stages, people commonly and repeatedly move their limbs as if they're dreaming. While the age of onset is variable, ranging from 13 to 60 years, the average is about 50. It can be detected prior to onset by genetic testing, although this is not always reliable. Death usually occurs 6 to 36 months after onset. So can you imagine 36 months of all the symptoms that we've noted already? It sounds like hell to me, just absolute hell. As you go forward, so the cause, as we've talked about, is a prion disease. Again, our favorite folded friend, the prion. And it goes in depth here about which genes do what to what and whatever else. Ultimately, with fatal familial insomnia and the fact that it is effectively a genetic prion disease, it talks about all the different things it attaches to and how it affects things. Feel well that your odds of getting it are fairly slim. If you are worried about it, Clark, feel free to have some genetic testing done. That might tell you something. This is one of the rare ones where there are a few diagnostic tests that can basically point to it. And most of those are, a sleep study, a PET scan, genetic testing. But if you really want to be sure, once you're dead, we'll be able to tell you, much like the other prion diseases. Now, there are some what they call differential diagnosis, and there's a couple of other things that it quote unquote could be. And I'm sure you've heard some of these, like Kuru, bovine spongiform encephalitis, and chronic wasting disease. So the reality is, even if you don't have fatal familial insomnia where you die from not being able to sleep, you probably have one of these other ones and you're just as well screwed. And again, once you're dead, we will pop out your brain and have someone tell you for sure. Now, The rest of the diseases are going to be kind of similar. I wanted to talk about variant Creutzfeldt-Jakob disease just because it is the human form of mad cow. But one of the scariest things that I read about this is two people that died in 2019 and 2021, respectively, of this disease. And the scary part is that both of them were research technicians that worked for part of a group that was in France studying these things. Both of them had been exposed occupationally, accidentally, 10 or more years prior to their death. And both of them were exposed by being pricked with a contaminated tool. So all the times that you see in a movie where somebody gets a needle stick and later they're dead, that happened to these two people. And it took them 10 years or more to develop symptoms and then die. But it was of Creutzfeldt-Jakob disease. And it was only through their study of the disease. And then after this happened, for a while, there was a complete ban on the study of these until they had better safety protocols in place. And the hard part with these diseases is because they have such a long incubation period, again, depending on your genetics, trying to figure out the best way to protect people against those diseases was extremely, extremely difficult. So we've covered a number of the diseases that you may or may not have heard of. Let's go to some basics, like what can I as a person do? And that to me starts with who is at risk for a prion disease, any one of the ones that we've mentioned. Well, people obviously that have a family history of it. If you had a family member that got one of these diseases, say your dad got one and then you were born and then your dad passed away, you might have gotten one of these. You don't know. Obviously eating infected meat. And I've always looked for this distinction because a lot of what we've talked about is, especially with kuru, is eating the brain tissue. The more I've learned about this, the infection rate when eating, say, a backstrap from a deer should theoretically be very low, assuming that the person that butchered the deer processed it correctly. And I know a lot of guys that want to, when they shoot their deer, the first thing they do is cut the head off so they make sure they get a good trophy. That's where you get cross-contamination. They cut off the head, they sever the spinal cord, and then from there, cross-contamination happens. Again, the thing that scares me the most, given the amount of deer I've eaten in my life. And probably the third biggest way is infection from medical equipment or, and this blew me away, contaminated corneas. If you've ever had a corneal transplant, apparently that is a big way to get a prion disease. So if you ever go blind and you're thinking you want to see again, you might want to rethink that. With prion diseases overall, symptoms. How do I know if I have a prion disease? I woke up this morning coughing. Do I have a prion disease? Probably not. The common symptoms, though, rapidly developing dementia. We've talked about that, and the amyloid plaques and the impact on the brain. Difficulty walking or changes in gait, and gait is just your stride, how you're walking. Hallucinations, muscle stiffness, confusion, fatigue, difficulty speaking. If you have any of those, see your doctor right away, and then after you're dead, he'll diagnose you with a TSE. So that should be fine. Diagnosis. How are these tests or how are these diseases diagnosed? Well, because most diagnoses and most of the tests don't really get started until people are really experiencing some pretty profound neurological problems. You can have an MRI, that's a scan of your brain, obviously, and that often will show the impact of the spongiform part of this, where the brain is being slowly turned into basically a giant piece of Swiss cheese. Supposedly an MRI will show that. Now, given that we know that Alzheimer's can cause that, Parkinson's can cause that, a myriad of other conditions can cause that, it's not always going to say, yes, you had a TSE. Samples of fluid from the spinal cord, these like a lumbar puncture, supposedly these are better because you might actually get some prions out of the fluid. Will they show the plaques? No, but with some very sophisticated, expensive, and when I say expensive, something nobody can afford, they can isolate the prions and tell you whether you have a prion disease. Now, nobody does it and no insurance company covers it because if you do, you're already dead, so it doesn't make any difference anyway. An electroencephalogram, which analyzes brain waves. This painless test requires placing electrodes on the scalp and often can locate misfiring brain waves. Now, again, because there's 100 other things that can cause that, not the best diagnostic tool. Blood tests, obviously, but those do next to nothing. And then neurological and visual exams to check for nerve damage and vision loss. But again, because there's so many different things that can cause those, we're still back to, we'll pop out your brain once you're dead, and then we'll tell your family what you died of. So how are prion diseases treated? Well, they can't be cured, but there are certain medicines, and we've seen this with Alzheimer's, that can slow their progress. The medical management focuses on keeping people with these diseases as safe and comfortable as possible despite progressive and debilitating symptoms. So, as we've discussed, if you get a prion disease, make sure your will's filled out because you're done. Can these diseases be prevented? Now, we've talked about cleaning and sterilization, how the rules and the suggestions for sterilization have changed in the last few years. So that part's important. But there's also some really basic and kind of like, well, that makes sense. Like if you have, or you think you might have any one of these diseases, whether it's CJD, if you get Kuru, if any of these diseases, obviously don't donate your organs or tissue, including corneas, and let people know, especially in your, quote unquote, last wishes. And then newer regulations that govern the handling and feeding of cows are also trying to prevent and help prevent the spread of the prion diseases. Now, living with these diseases, there's a hard reality here. As the disease progresses, everybody ends up needing help taking care of themselves, and most people end up in some sort of a facility where their needs can be basically tended to around the clock.
How contagious is this if the person, like, I don't know, if you don't get like a needle in that person, then that accidentally stabs you? Like if someone's just in a nursing home and has this.
Well, the reality of this is it's not a blood-borne disease. Okay.
Yeah.
So it's not in your blood. There is limited information that says in the perfect circumstances, it could be aerosol-borne. But that's more, I take an infected brain and I put it in a squirt gun somehow and I squirt it into the air. I mean, who would do that, right?
Right.
The people that have been, infected as an occupational, call it the quote unquote needle stick, had an instrument that had been in the brain of an animal with that. So it was right there. So bloodborne, you're not going to get it. Now, I will tell you that the Food and Drug Administration of the United States, because of mad cow disease, did ban the import of, this is going to sound terrible, but of foreign sperm for sperm implantation because of worry of things like mad cow disease. Mad cow disease was at the top of their list when they decided to ban that. So if you wanted to go to Scandinavia now and get some semen from a 6'6" blonde guy, to make sure you can't anymore. And it's because of mad cow disease that you can't.
Yeah.
Despite that, there is absolutely zero evidence that any of the TSEs are sexually transmitted. So it is short of the sporadic, and that's the development. And I think sporadic is a term for, we don't fucking know. That's what sporadic is the coverall term for. Versus genetic, my dad had it, or the obvious, I ate a human brain or I ate an animal that was infected. So I think the sporadic is just the catch-all term.
I'm really regretting drinking out of that skull cup now, Clark.
That's
So
all on you, bro. That's all on you.
Hey, if something happens, you guys know.
He made me kiss one.
ooh,
Yeah,
Oh,
that was a whole separate thing.
okay.
That makes you an accessory to murder.
I was gonna say it's been nice knowing you, Megan. Sorry. Um, so key points before we break into a little bit of pop culture and just some kind of basic points about this. Prion diseases are extremely rare. Extremely rare. It doesn't even pop into the top 1,000 of things that kill people in the United States every year. It's not even there. You're more likely to get hit by lightning than you are to get prion disease.
Good.
The other side of that coin is prion diseases are always fatal. There's no cure. There's no treatment. Like I said before, any treatment is supportive. It's palliative care. There's nothing you can do about it. All you can do is try to protect yourself from it. And to do that, you need to know something about transmission. So it's been widely recognized that prion diseases can be transmitted in one of three different ways: acquired, familial, or sporadic. And that's the I ate the meat, it's genetic, my dad had it, or the sporadic, we don't fucking know. It's often assumed that the disease form directly interacts with a normal form to make it rearrange its structure. So there's been an idea put forth that we have the protein X hypothesis, that is as yet identified cellular protein X, that enables the conversion of the PRPC, that's the normal one, to the PRPSC, which is the abnormal one, by bringing a molecule of each into a complex. Now, there's a lot of people that believe this. There's a lot of people that don't. The research is so far inconclusive, and the reality is, from a pharmacy standpoint or a medical standpoint, there's probably little to no money in this, so nobody really researches it. Ultimately, the primary method is through ingestion, and that's eating either contaminated brain or brainstem, or through eating a piece of meat that has had the fluids from those contaminated things deposited on it, and that goes back to the poor butchering that we talked about. That said, it can be transmitted through urine, saliva, and pretty much any other bodily fluid. They also can linger in soil by binding to clay and other minerals. So that goes back to plants can get it. There are a couple of theories about prions being able to infect versus various animal scats and manures. The scary part of that is that they have proved that the prions can exist in manure. And since manure is present in many areas surrounding water reservoirs, and as well as many that are used on crop fields, it does raise the possibility of widespread transmission through the waterways. Now, in January of 2011, researchers had discovered prions spreading through airborne transmission on aerosol particles in an animal testing experiment focusing on the scrapie infection through laboratory mice. The preliminary evidence supported the notion that prions can be transmitted through the use of, this is going to be odd, but urine-derived human menopausal gastotropin administered for treatment for infertility, which is widely used when it comes to treating infertility. So if you used those human menopausal cells to help treat infertility and there was a prion present, it's possible to pass it on through that. Now that it's possible, there aren't any existing cases of it. I dug and dug and dug and could not find a single existing case where it happened through treatment of infertility. They're just saying it's possible.
So, okay, when you say going back to the grass and soil and stuff, like if an animal infected dies, whatever, the other animals come and eat the grass, I'm assuming the prions would be in the water within the plant and the soil and that kind of thing, since we're not really talking about an infection.
Well, your timing is perfect. So in 2015, researchers at the University of Texas Health Center at Houston found that plants can be a vector for prions. When researching fed hamsters grass that grew on a ground where a deer had died with chronic wasting disease was buried, the hamsters became ill with chronic wasting disease, suggesting that prions can bind to plants, which then take them up to the leaf and stem structure where they can be eaten by herbivores, thus completing the cycle. It is thus possible that a progressively accumulating number of prions in the environment. So a deer dies, it decomposes into the ground picks up the neutrals, or the nutrients, the minerals, and as we talked about earlier, things that get stuck in various minerals in the ground and the various clays. Like I live here in Minnesota, we got a lot of clay.
Mm-hmm.
Great. One more thing that's just going to keep me from not sleeping tonight. I haven't slept in like 3 days because of this research. So I hope you guys appreciate this shit.
Yeah. Are you sure that's not fatal insomnia?
Well, I'll tell you what, Clark. If it is, I'm gonna ping your phone once every 15 minutes for the next 6 to 36 months. Okay.
Thank you.
Yeah. So just enjoy it. Okay. So we talked a little bit about sterilization, and the fun part about sterilization is that generally when you sterilize something, what you're doing is neutralizing the nucleic acid that it uses to build more of itself. Because prions are infectious by their normal versions of a protein, sterilizing prions requires the denaturation of the protein to a state in which the molecule is no longer able to induce abnormal folding. In general, prions are quite resistant to proteases, heat, ionizing radiation, formaldehyde treatments, and most of these things don't actually, quote unquote, kill them as they're not alive. They render them ineffective. However, this ineffectivity can be affected by the environment, chemicals around it, and some prions have been proven while in an ineffective or dormant state, they can be, where's the word here? They can be renaturalized and once again become infectious in the right environment. So they can be effectively neutralized, made dormant, but then in the right environment, they can effectively wake up. So again, if you wanted something that makes your butthole pucker a little bit, think about that. Something that isn't alive can be neutralized, but just sit and wait. And if the environment is correct, it can come back. Now, nobody has been able to achieve that in the lab, but they have seen it be achieved in nature. So again, the whole making prions reproduce themselves in a lab has been highly unsuccessful. No one's ever been able to do it. But while being monitored in nature, they've seen the prions replicate themselves, and they've also basically seen the prions Frankenstein themselves back to whatever they call a life. Again, to me, incredible. Something that isn't alive can replicate itself, can put itself into a forced hibernation if it needs to, and then come back when the time is right.
This is like the greatest setup for thawing out the permafrost movie.
Oh, but dude, don't even get me started.
Like who knows what's under that ice?
As a video game nerd, it makes me think about like Parasite Eve, but that's about mitochondria and not about proteins in your body. But same thing. Like, what if they just decided one day to wake up and say, "Hey, we run your body, you don't."
So now that we have immersed ourselves in the history and the science that is prions, and ultimately acknowledging that nobody fully understands a prion or fully understands how it works, there's a lot of conjecture, a minimal amount of research, and some more or less accepted that's probably how it works. Now, when it comes to the proliferation of the prion, there's many, many accepted forms of transmission, many accepted diseases that are caused. And that's all scary. And honestly, when I get off here tonight. I'm probably just going to sit and cry and suck my thumb for a while. But keeping things fun, let's talk about prions in pop culture. So as I told you guys before we recorded, my first experience with a prion in pop culture and really getting to understand what it was through a series of books by an author named Jonathan Mauberry. The best ones, honestly, are Dead of Night and Fall of Night. If you need a book that is riddled with character, riddled with what you might call garbage science, just because it's fun, but also zombies, read those two books because they are very, very fun. They're popcorn books, to be sure, but they're fun to read. If you can do them on Audible while you're doing the rest of your life, even better, because they're just fun to listen to. But so check those out. Again, Jonathan Mauberry, he's done lots of books. He's got the From Dusk Till Dawn series. Those are not From Dusk Till Dawn, from Rotten Ruin series. And they're more young adult books, but they're still fun, still kind of under the same pretense. When it comes to movies, I'm sure everyone here has seen the movie Zombieland, right? Okay. Well, Zombieland, if you listen, Zombieland is based on mad cow disease. That's what it's based on. And one of my favorite zombie movies of all time, just something you can't help but like. It's just kind of great. The most fun, I think, pop culture reference to the prion is in what is basically a video game, but it's more of a tablet/phone video game called Plague Incorporated. I'm not sure if anyone's ever played Plague Incorporated. When you play Plague Incorporated, your goal is to kill the world. And to kill the world as fast as you can. Now, I've played that with viruses, bacteria. They even have a mode where you can try to kill the world with zombies. As it turns out, and a lot of this makes sense, trying to kill the world with the prion is pretty much the hardest level in the game. It takes a lot of thought and a lot of perfect things to happen to kill the world with the prion. Now, it can be done, but it's really difficult. But that also tells you something about the prion, which is maybe one of the things that takes just the tiniest bit of fear away from this little not alive, somehow replicating, turns you into a drooling idiot, and then you die because you haven't slept in 6 months. If you're looking for a fun little game to play, by all means, check out Plague Incorporated. I think the last time I checked through my app, it might have been 99 cents or something. It's not a huge expenditure. But if you're having a bad day, it's a really fun way to kill the world just because you can.
Oh, yeah.
So getting to the end of this, I wanted to, there was a lot of sources that went into this, and I wanted to give most of the sources some credit so people know that I'm not directly ripping off something that somebody else said. So my main sources are Scientific America, obviously Wikipedia, Learn.genetics, the National Library of Medicine, NPR, the CDC, and the Center for Food Safety. All of this information comes from one of those sources in one form or another. So after talking for almost 2 hours straight, everyone here, give me an idea of your perception of the prion.
All right. Well, it's kind of a question, but when you were saying that there's basically like 3 genetic types to watch out for in terms of people or hosts or whatever I know this thing isn't alive, but all right, so you got people that either are going to get it immediately or close to it. You have people that don't have to worry at all, and then you have people that are going to get it way down the line. Since this thing is like it just by default so rare, could it be that most people are genetically built to like this not be a thing, or I mean, are there tests that can say whether or not your genetic makeup is susceptible to this, that, or the other?
So there are genetic tests, but it's a genetic test that you likely wouldn't take unless somebody in your family was already suffering from a prion disease. Like, you wouldn't know to take it. You wouldn't be like, I should rush out and take that genetic test.
Yeah.
Now, knowing what they know about the two two forms
Mhm.
when it comes to the variant of Creutzfeldt-Jakob disease, and that's the M and the V's. With those people, the big differentiator was the onset of symptoms.
Okay.
The people that were of the M class got ill very quickly and generally succumb pretty quickly, and we're talking like 12 to 18 months. Now, the V factors in that sometimes didn't have any symptoms for decades.
Yeah.
But what it is exactly about their genetic makeup, that M versus V is only a small portion of the genetic makeup. So it's the same as people identifying a predisposition to breast cancer. So why would somebody identify that? Because it's prevalent in our society. So it makes sense that people put money and research into identifying a gene that says I may or may not. The hard part with the prion diseases is they're not prevalent. So going into the late 80s and the early 90s and almost into the 2000s, they were throwing a lot of money at research. And that's when most of the primary discoveries were made about it. But then as soon as it wasn't on the news anymore, it got unpopular and the money dried up. So the research effectively stopped.
Okay.
What we have now that we know about it has been general disease reporting, both from the CDC, from the World Health Organization, and through a couple of other. There's one in Japan that I cannot remember the name of because it's got a weird acronym, and then there's one in France too that has been working on, these. But it's not that there's teams of 100 people working on this. There's a couple, and for the ones in France, you can see how that worked out for those two people. They worked on it, got stuck, and 10 years later were dead. So, but it's not happening. I know in Minnesota, anecdotally, I know of enough people that hunt and do things like that where I've heard of people that have gotten this. Do I personally know any of them? Nope. I've never met one. So I think most of it's anecdotal. But it's like anything else until it becomes widespread and it's happening and we're seeing it. There's no money for research. We all know that curing a disease is not profitable. Treating the symptoms is profitable. That's what drug companies do.
True.
But I'll say it again, like with my dad who died of Alzheimer's. All of that fit Alzheimer's, but a lot of that same stuff fits Creutzfeldt-Jakob disease. So how do I know? There was no autopsy. I don't know. And my dad growing up, I know he ate a lot of deer growing up. He grew up basically in the flats in North Dakota. They ate a lot of deer growing up. I don't know. Could be.
Well, extremely disturbing. That's for sure.
It is. And for me, the takeaway is that it is the prion diseases are, one of the most terrifying of medical conditions. And well, once the symptoms kind of manifest themselves, and one of the symptoms being hallucinations, that's fucked up, you know, and it is too late, and there's a literal degradation of the brain that sets in. So that's scary and that's sad at the same time.
Well, it always makes me wonder for people that you hear about, say, on the news that went bonkers and did something and they were schizophrenic or they had some other mental disorder. It's like,
Hmm.
does anybody bother after, they're gone to test and to see if
That's a really good point.
maybe it was something else?
Well, the
I mean,
the Kent State shooting back in the 60s, wasn't Charles Whitman?
Yep.
He actually, his note he left was examine my brain after I'm dead.
Yeah.
Like, yeah.
Wow.
And he went on a shooting spree. So,
Well, and that's, I think, one of the rare cases where somebody has a moment of lucidity and knows that something's wrong. And the best that they can offer is study me when I'm gone. So maybe you can prevent this later.
yeah.
But,
And
but I do often think about people that when you see people like, the guy in the street that won't put the knife down and the cops shoot him, or the guy that jumps off a bridge, and to Rose's point about hallucinations and what that can do to your mind, does anybody bother? Is there any protocol to test for some of these things to see if maybe that's what it is? And maybe that's what it is, and maybe we can bring it more into the forefront. I don't know, but I often wonder because the hallucinations, and that's kind of one of the things that scares me the most too, is not, I mean, and this is going to sound dumb, and I'm not, this is not a public service announcement, but it's one of the reasons I don't do drugs is because I don't want to ever think that I'm not in control of what's happening. Like maybe I'm a control freak, whatever else, but I don't ever want to think that I did something and it wasn't of my own free will, that it was like a different part of me that did something. I don't ever want to be in that place because I don't want to have the guilt that could go along with an action that ultimately wouldn't be something that I would normally do. But then when thinking of this in context of my brain is being eaten alive by a misfolded protein that's out of control that can't be killed because I ate a hamburger or so, I mean, that freaks me out. And I wonder as we go forward if because the research that I did testing for this is not part of a normal autopsy. It doesn't happen. Somebody dies. It's like my father died of Alzheimer's, okay? And symptomatically that's what he had. His death certificate said natural causes, Alzheimer's, and then all the other medical conditions that he had, but he wasn't autopsied. Nobody took a piece of his brain and studied it, So like, I always often wonder, well, so how do you actually know? Because the symptoms pointed to that. That's how you make a determination. And so it makes me wonder for something like this, like how many people, and let's be honest, it might be 1 in 1,000, but if it's 1 in 1,000 and 1 million people die in this country every year, maybe it's more predominant than people know. But it's not tested for, so how will we ever know?
Or the people that even die before symptoms manifest. So, like, hypothetically, okay, you had a father who, dies of Alzheimer's. It's not, autopsy doesn't, go into any of that. Say you died early, but you already had kids. You're not autopsied, and therefore you never had symptoms manifest. And now you have kids that are younger, and they're time bombs at that point.
Very well could be, and you have no idea.
Yeah.
And that's
It's crazy. So
yeah. Well, but that goes back to the point about like the breast cancer gene. Like ferreting out the breast cancer gene makes sense because breast cancer is so prevalent in our society. I mean, everybody here knows somebody that's had breast cancer. Everybody. If you say that you don't, either you're lying or you haven't been paying attention to the people that you know. Everybody knows somebody. But when it comes to a prion disease, I mean, before tonight, I would imagine that 2/3 of us had no idea what a prion actually was. So to say that I knew what it was, look, I'd heard of it. Okay, what does it do? It was in a news story I read about 10 years ago. So I mean, so it's not dominating the social commentary. So I can't imagine. Oh, excuse me. I can't imagine that it gets any kind of a play when it comes to research, and it definitely doesn't get any kind of attention when it comes to someone's death certificate. Other than, I know there's been a couple of cases in neighboring Wisconsin, and these were back in the early 2000s, where people that were big hunters would go and they'd go out, they'd have these big parties where they'd hunt a whole bunch of different things, and they'd all get back together, come back. They'd have basically a big party. They'd eat a whole bunch of different things, a whole bunch of different animals. And then within a year or so after that, a whole bunch of the people that were there started to develop these weird neurological symptoms, and then a bunch of them died shortly thereafter. And it turns out that it was the Creutzfeldt variant. that they got. But because it had been so long, they could not pinpoint where it came from. You know, there was nobody had a record of Bob ate this deer and that's where he got it from. Because again, through my research, you can get this from a squirrel. You know, a squirrel can have this. A fox can have this. A deer can have this. An elk can have this. A goat can have this. A sheep can have this. A cow obviously can have this. Most of your domesticated animals, so your cats and your dogs, don't seem susceptible to it. So you're probably not going to get it from your cat. But for some reason, pretty much anything in the wild, it's possible. If you decide to kill it and eat it and either consume the brain, which I don't know why you do because it doesn't seem like it would taste good, or you just have poor butchering practices. And I know a lot of guys that hunt, and they're all good guys, but a lot of them do shit that's pretty slapdash. So I often wonder if, you know, all this tasty jerky that you laid out for me was at one point not covered in spinal fluid because you were in a hurry, you know? So, yeah, again, it not something that I worry about on a daily basis, but when I think about it, it makes me want to lay down in a corner and cry because it's scary. It's just scary. Now, do I think I'm going to die of this? Probably not, but being the person that I am, being the big zombie fan that I am, I mean, I hope if this happens, I hope that I don't die and at least I turn into a zombie. Because at least that would be something, you know. I just don't want to keel over and die, and that's the end. I want to come back and fuck some shit up if I can. Well, anybody else? Any thoughts? Megan, any thoughts on prions?
I don't know if I want to eat a burger for a while.
Truth be told, I don't think I'm going to either. I'm not sure I'll go vegan, but there's going to be a lot of salads this weekend for sure.
Yeah.
Mm.
But then you can get it from a salad.
Well, that's true. You can get it from.
Yeah.
Well, great.
No one's safe. No one is safe. Just stop eating altogether.
Chickens aren't wild.
You know what bothers me is I'm on a whole bunch of really old farmland. And I know certain areas that like where deer have died and this and that. But man, I don't know. It just makes me think. And I also have a lot of clay here. Like there's this weird kind of point on the river where like all the stuff on this side that's all hilly, it's just like this thick red clay. So yeah, that's just bothering me. I'm just kind of like scanning all my surroundings right now.
You were also
Yeah, I know. I have plans on like growing crops next year.
prions from it.
Well, and that's the scariest part. And I think, for me anyway, because this is such a ultimately in our overall zeitgeist, it's not something anyone ever talks about. But like I said, I was alive and a functioning human being in the 80s when this all started. And I can remember, you know, the news stories of semi truckloads of cows, you know, well, these cows came from Britain, and you had people offloading cows and shooting them and setting fire to them, you know, just to get rid of the British plague, you know. And then fast forwarding to when the ban was lifted, and it was like, oh, the ban's been lifted, and then here's the British cows, and people were doing the same thing. It was nope, British cows, shoot them, burn them. We're not doing it.
I remember stuff in the early 90s. When this was going on.
Mid-90s was my thing where I remember all. So
wasn't there an uptick in the mid 2000s? So I remember under Bush there was something. I remember he was president, and then there was an issue with mad cow again.
Okay, so was there an uptick in like infected cows.
Well, that destroying like they were, from my childhood memory.
Okay, so when you got into the mid 2000s, there was still a lot going on, and we can talk about that. So in the middle of 2005, the big ruckus was that there was a case of BSE that was discovered in Texas.
Okay.
And the big thing there was it was a cow that had lived its entire life in the United States. So it didn't come from somewhere else, and it wasn't fed some feed from somewhere else. It had been here and been fed supposedly non-contaminated things its entire life. That was the first case of, we'll call it, true homegrown BSE. It was the first case. That was in 2005. So in that case, there were some cattle that were culled. Probably about 9 months later, there was a case in Alabama, and there were some cows culled again then. But between those, there was never anything got to market sort of scenarios. And it was another, I think, 5 or 6 years before we really had another pop-up of it, and it was in California, and it was a dairy cow. And the big thing there is that it was a dairy cow. And what do dairy cows give us? So, but from there was not another big pop-up after that. The only other thing that really came on the radar is that by the end of that year, Japan issued a complete ban on any beef from Brazil because there was a cow that had died. I think it was 2 years prior to that reportedly had disease-carrying proteins. Now, they were never identified as prions, but they called them disease-carrying proteins. So effectually, you can call it a prion disease. But after that, there was not a ton of uproar. And for all the research that I've done, most of what we hear about now, just in the everyday vernacular, is people that are getting one of these diseases, whether it be Crutchfield-Jakob, whether it be the variant. There's obviously hasn't been any cases of Kuru, but like the last person that died from the original call it strain that came out of Britain was less than 2 years ago. So, and it started in the late 80s. The first actual death was in 1995. The first acknowledged death was in 1996, I believe. So again, depending on your genetics, whether you're an M or a V, or as they prove now, you can be a combination of those two. And there's got to be a million more different genetic variations that probably, but again, to your point, say whether you're completely fine and nothing will ever happen to you. But is that somehow related to the same people that get Parkinson's and Alzheimer's?
Yeah.
Does that mean you're going to get a prion disease? I don't know. Not a researcher, not a doctor.
I mean, well, the other thing is like they've been having a squirrely time trying to pinpoint the exact mechanism of Alzheimer's, and what if it is a genetic predisposition to a type of prion disease, and that's the main thing, because there's the whole thing with the amyloid plaque and all of that, but it seemed like that was some shoddy research that was meant to issue a drug out. But this whole thing makes me think, like, I don't know, maybe there's a pathway there. No, I'm just wondering if Alzheimer's could possibly be, I don't know, a something related to this. That's all.
Well, everything that I see in the research and everything that's current says that Alzheimer's is a prion-like disease. Now, have they gotten to the root cause of it? They haven't, but a lot of this ultimately still still backs up to you have a disease that comes in, takes over protein production, turns it into something that it's not, leaves deposits in the brain, affects neurological function, ultimately causes death. Now, I think if people were to stand up and say, hey, Alzheimer's is a prion disease, that the sad fact is I think people would go, well, that's mad cow disease. What are you talking about? And people wouldn't take it quite as seriously, which is probably why someone doesn't stand up and wave a flag and say, this is what it is. But I think honestly, only time will tell. And it's like a lot of other diseases when you start tying things together and you start making connections. I mean, maybe that's the place where we figure it out.
I wonder if they took the average Alzheimer's patient and it took like a spinal tap of the fluid and then injected it into lab animals, if some neurological disorder would manifest after that. I don't know how you would test that. You obviously couldn't do that to people, but man, it's fascinating. It's just disturbing, but it also all of this kind of screams to me that this most likely is like, especially if it's some small strand of protein kind of error, it seems like it's ancient, like, and we're just now developing like the vocabulary and the way to identify it, because who knows what, like, I don't know, did Genghis Khan have like some domesticated farm animals, and something happened, and then they like burned them all or whatever, and then moved on, and nobody, it was just a thing. Like, who knows how many times this kind of thing has popped up throughout history.
No, I think you're absolutely right, man. And just with, I think when it comes to our pop culture vernacular and then how people are just living their lives, I think Alzheimer's, because how many people, I mean, Rosalind Carter, what did she die of? She died of dementia just a week or so ago. So it amazes me that we don't somehow tie these things together. And I suppose I'm foolish if I think that there's nobody out there that is researching this. I just don't know. I don't know what kind of money it gets. And the reason I think it probably doesn't get a lot of money is that if you tied something like dementia or Alzheimer's to the amount of beef that Americans eat, it would murder our cattle industry. It would just bring it to its knees. Because for a long time, that's what it did in Britain. It brought their cattle economy to its knees. There was nothing for the longest time. And even now it's still trying to struggle to come back. Nobody grows up in Britain wanting to be a cattle farmer because there's a ghost that follows it everywhere. So, if you were to go on TV and say researchers have linked Alzheimer's disease to eating beef as a child, tomorrow, the meat section in your grocery store would close. McDonald's would be out of business. Wendy's would be out of business, and every steakhouse and whatever. So, there's a lot of socioeconomic reason to not say it out loud.
Like, I don't like, and I don't know. Obviously, I don't know what causes proteins to misfold, or if it's, I don't know, just random, just all the particles that are in reality. It's something the entropy. Eventually, something goes wrong. But I've never liked just huge factory farming. It's like, I get it. Going down, people all around here wouldn't be able to get food. Like, nobody would know how to get food just in my area, and I'm in a relatively rural area, kind of close to town. But it's like, thinking about that and what that, I've always thought that, like, kind of decentralized local farming should make a comeback, because it seems like our monocrop agriculture is coming to a expiration date, and then you have just the massive amount of horrific living conditions that animals and diseases can propagate in. It's just always been kind of creepy. Like, going to a local farm is great and all, but it really, you take a hit in your wallet getting some like beef, is like top tier.
Well, see, and for me, I'm always willing to take that hit because I love the idea of supporting a local farm. I've always loved that idea. There's the realist in me, this little voice that says, so what advantage does this centralized farming have over the decentralized farming? And the only real advantage that I can see is the regulation. Now, I'm typically not a fan of regulation. I'm typically government hands off. There is a point where, as a farmer, I know that things like testing and things like that cost me money, to me provide little value other than, oh, maybe this one was sick, I'm going to toss it. But I never had to do that before, so what difference would it make now? But it's all under the umbrella of preventing things like a prion disease outbreak. So I understand it.
Yeah.
But but I'm so hard pressed to, like, I don't want to put that cost onto the local farmer because they couldn't bear it. They would go broke. And I don't like government regulation because I don't like government regulation. But this is one of those rare times where it's like, maybe maybe it's okay. Maybe I can subject myself to, because I've bought quarter and half cows from local farms. I've bought my neighbor and I went in together on a pig, and my neighbor went and shot it himself. So there was no regulation in that. It was, here's your meat. And I much prefer that because I think it's simple. I think it cuts out the middleman. I think it maximizes the profit to the farmer, and it minimizes the expense to me. But there's always that thought in my head. It's like, what did this thing get into before it got to my house? And I don't know. So that's the part I think that's going to keep swirling around my head. Like,
just this talk is valuable to me because, like, if Western civilization falls, not saying it will, but I'm not a hunter. Like, I know how to kill something, but I'm not a hunter. And so knowing to make sure that I'm keeping the spinal column and head intact while I remove meat and organs, that seems like a pretty nifty thing to know if things got to that point.
All you have to know is
I don't know. My mind's just spinning with, like, contain. What can I do?
If you truly want to butcher an animal for your own consumption, there's some very basic things you have to know. You have to understand primals. You have to understand guts, or the gut sac, and its removal without contamination. And then beyond that, you just have to understand what constitutes meat and what is not meat. And on just about any animal, it's pretty damn straightforward. If it's a bird, breasts, wings, thighs, legs. If it's a mammal, you've got chest muscles, back muscles, leg muscles. If you're super hungry, neck muscles. But, like, for a lot of that stuff, from the shoulders up, you can just stay away from it, unless you want to put the head on the wall. Just stay away from it. The rest of it is so far away from what we're talking about that unless you shot it and you got it through the spine, and that happens sometimes, you don't have to worry about that cross contamination. It's proper processing, expedient processing, and then honestly proper disposal of what's left. That's it's not complicated. I can process most things. I'm not an expert by any means, but anything from a squirrel, a fish, a deer, a hog, I can process most of it. There's just a lot of common sense that goes into it, and it's the thing that always gets me, and especially when we talk about this whole prion thing, when you talk about a side of beef, right? When you see a side of beef, the head is removed, the hocks are removed, and it's cut down the middle. Okay, that's what a hanging side of beef looks for. Well, when you cut it down the middle, what else are you cutting? So you're cutting all the vertebrae, and you're cutting the spine. So that's the part that's made me start to rethink what should I actually buy? And is the glorious prime rib that I make on Christmas actually worth it? Because
Man, I don't know. I got to be more careful. Like we were hiking and off the like kayaking, hiking up a hill, ton of farmland, and I just kind of stumbled across a bone in the sediment, and I was like, "What?" And obviously, I'm gonna dig it up, and now the I just didn't know, like when before all of this, I pictured prions as more of uh a fleshy, there can be cross contamination now, but now that I'm absorbing all of this, but I was picturing like more or less things within uh like wet tissue, and then once it was dead and especially like burned or something or rotten away, it's gone. Like the thing that is very disturbing to me is staying in the soil, getting in the groundwater, getting in the leaves and the grass and the whatever. The fact that this doesn't break down like anything I've ever heard of. It's like a forever chemical, but it's worse.
yes, there are documented cases of brains stored in formaldehyde. The longest one I saw was like 38 years. And the prions, once the brain was dissected and put under a slide, the prions were still there and they were still trying to produce these plaques by reforming themselves. They were still trying to do it after close to 40 years in a jar of formaldehyde.
Man, well, it goes back to what you were talking about, like if this could be leverage, like how we figured out, those burls on trees that I mean, CRISPR essentially came from that. I mean, us understanding how viruses hijack what a cell is doing and then repurposes it with new information. Like the way we leveraged that to genetic modifying to where it's like become way simpler. I can't help but think that there's some template within this weird thing that could be used for good, but at the same time it just sounds like it sounds like so much worse to me than like a bioweapons lab. Like the old thing of like something leaking out of a bioweapons lab. This seems so worse because it just doesn't go away.
Well, I mean, ultimately, a prion is, if you look at today's society, a prion is the equivalent of the Chinese Communist Party and the way that the Chinese Communist Party does things.
Mm-hmm.
They infiltrate a society. They take the people of that society and over the course of years and decades, make them slow and stupid and sloppy and ultimately take over. That's
just having this conversation the other day.
Okay, well, we had the TikTok conversation already. We did.
Yeah.
But that's the equivalent, and it's again based on a predisposition, right? Because like I'm not predisposed to something like TikTok. It's not going to ever entertain me. Okay, but there's lots of people that does. I mean, and that's fine. But people often don't understand the repercussions of their acceptance of a thing, but that goes back to me and maybe me not understanding the repercussions of my acceptance of my neighbor bringing me over, 5-pound bags of marinated deer jerky to smoke, and I just dig my hands in and I put it on the trays. I drag it out to the smoker. It's out there for 4 hours. It's done. I'm like, yep, that's done, and then I go off and then I have snacks forever. Maybe I've infected myself and I don't know it. And in 40 years, I'll die of Alzheimer's, but it might have been something else.
Do you think it's more likely to get it from a farm than the wild? Well, obvious, I guess you have the regulation side of it now. Even though it's light, it's something.
I'll be honest, I think it's probably more likely to get it from the wild only because of what I know now about how it can be in the soil and it can be in plants. And but then I would also think that that's those same genetic follies that apply to humans probably have to apply to a deer too. Maybe that deer's dad had it And
yeah,
so I don't know. So there's so many variables that go into it. It's almost impossible for me like to mathematically even plot it out. But if I were to say more or less, I would say, well, I've eaten meat my entire life. I've eaten deer my entire life. I've eaten wild deer that people have killed and may or may not have observed the best butchering practices. I've eaten pigs that have come off of a farm where butchering practices might have been questionable. So, am I more or less? I'd say probably more, but I'm not going to know until somebody scribbles something down on my autopsy report if I insist that it's
yeah,
done in my will, that somebody
yeah.
checked for a prion.
The other thing that bothers me, I'm obviously I love dogs and cats. The thing that bugs me is like their feed. So like, you know, you could go the raw route, which mine have kind of a mixture of kibble and some raw food. But there's like almost no regulation on animal food. And a while ago, it's one of those things that was going around. I forget what the euthanasia drug was, but it was in detectable amounts in some dog brands. And the theory is that there weren't any intentional tainting the food with a drug. It was that they were using like crude protein from kill shelters and recycling. Is that, I don't know if that how real that is or not, but the just what I know of how unregulated that whole marketplace is,
Yeah, I heard the
kind of
same.
irritates me.
I heard the same thing. And I actually did ask my local veterinarian about that.
Yeah.
About because my local veterinarian does work with places that have to humanely euthanize animals because reasons. Let's just say reasons. And what he told me is that his experience in the place that he works with, those animals are almost always cremated.
Okay.
So they're not passed off to a secondary market to be used in something like that. My local vet, who is just a fucking saint, the guy is just a fucking saint. I had one of our cats was there today having some dental work done. This guy's just a fucking saint. Um, anyway, what he told me is that from what he knows, it is not common practice to euthanize animals and then send them off to a secondary market to have their meat processed for anything. Usually, animals that are injected with those life-ending drugs are cremated, and
Okay.
that's just the end of it. Now, are there unscrupulous people that do things? I'm sure. It wouldn't surprise me in the least. But I think that just goes back to kind of what you were saying about like how you decide to feed your animals. It's like for my animals here, it's like my dog's food is $100 a bag,
Yeah.
which is ridiculous. But my dog is also almost 16 years old, is still kicking. She's got some bumps and some other shit that I can't really explain. And even the vet, she was just into the vet like 3 weeks ago to get her, call them what it is, bladder tightening pills because she's getting a little old. And he's like, you know what? She's like 6 years past her expiration date. She's got some bumps and shit. If things get weird, let me know. Otherwise, just enjoy your dog and keep going. But I think that says something to the food that I feed her, because like my dog too. If I go to the store and I occasionally will buy a giant like cowboy ribeye, right? The bone and everything. I'll trim off the fat, and I don't give my dog the fat because I don't think that's good for her. But if some of the fat has some raw, really good red meat in it, I'll give that to my dog raw, And she doesn't ever get the trots or anything from that. She just is like, oh, hell yes, keep it coming. But I think that says something about the quality of what you give your animal, And
Oh yeah.
my wife's wonderful cats that like to come down here and hang out, these two cats, they get some wild, like hypoallergenic rabbit based, and it's like, but at the same time, it's like they're 12 years old and their biggest vet bill now has been going to the dentist because they had some tartar built up and they had to, so I think that ultimately the quality of what you give to your animal isn't any different than the quality of what you give to yourself, you know. Now, like, you give yourself the highest quality stuff, you were really regimented about it. Like, I'm not. So there's a reason I'm out of shape and my joints hurt, and there's a reason for it, you know. So you just, it's with any of this stuff, and like, I'm going to say this again, I think this prion thing is absolutely fascinating, but it's fascinating to me and it really tickles my brain. The odds of it happening to me, I think, are fucking slim to none, right?
Yeah.
But at the same time, in the general umbrella of the world, you know, if you treat your body like a temple, you're going to get back what you put in. So as I'm sitting here smoking cigarettes and drinking beer, I'm probably going to get what I put in. You know what I mean? But I'm okay with that. And that's the whole thing, just being okay with it. If you are shovel by shovel digging your own grave, or whopper by whopper digging your own grave, be okay with it. If you want something different, do something different. And don't let anybody else in the world tell you that what you're doing is weird or whatever else. It's like you and I have talked at length about the lifestyle that you live. And when I first heard about it, I'm like, God damn, that's crazy. But then I think about it and it's like, no, it's not crazy. You made a choice and you're observing that choice. And that's what you're doing. And when I think about it in those terms, it makes perfect sense. Why not do that? At the same time, I've made a choice, so I'm observing my choice. And that's okay, because guess what? We live in the United States of America. You can do whatever the fuck you want, you know?
You can.
And that's what makes it a great place. And if the end of it, if you die of chronic wasting disease, well, shit, what a bitch that was, you know? Yeah.
I did it for the views.
Well, I definitely did not do it for the views. Yeah. Like I said before, if I told you the amount of hours I put into this research, you would probably first your eyes would get big, then you'd laugh, and then you'd say, "Really? Like, really?" But I much in the way that you observe your lifestyle and whatever else, like, I don't put that like level of energy into my lifestyle, but I put that level of energy into a lot of things.
Yeah.
And with something like this, I don't do anything halfway. I don't, because what's the point otherwise? You're either all in or you're all out.